This video shows a plate girder being tested under bending. The material used in this test is an aluminium alloy. While there are vertical stiffeners, they are not sufficient to prevent shear buckling of the web. The loading diagram shows the beam being subjected to 4-point bending. It is also laterally restrained at 4 points along the length to prevent lateral torsional buckling. The testing rig is now starting to apply a pair of equal vertical loads to the central third of the beam. As the loading is applied, the beam begins to sag. Under this loading arrangement, the shear force on the beam is uniform in the outer thirds and zero in the central third of the beam. Since shear is primarily resisted by the web in an I section, in this arrangement only the outer thirds are vulnerable to buckling in the web. As we can start to see, the deformation is confined to portions of the web between adjacent vertical stiffeners. The deformation leads to a plastic mechanism which ultimately causes failure. Let's look at the beam a bit more closely. These diagonal bands in the web, sometimes called a tension field, are characteristic of web buckling. At the end, you can see that the plastic mechanism also induces failure in the flange. The graph shows an initial linear relationship between the applied force and the vertical displacement. This corresponds to the bending of the beam. However, once shear buckling of the web occurs, the stiffness progressively reduces until plasticity causes failure, and the load carrying capacity falls away very quickly.